afternoon, everyone, and welcome to my talk about Hibernate. Well, all of you probably know Hibernate as an OR mapping framework that makes it pretty easy to persist data in a relational database. But you can do a lot more with Hibernate, and that is what I want to talk about today. First of all, I want to take a look at multi-tenancy with Hibernate. Who of you is implementing a multi-tenancy application? Okay, not that many, but at least a few. Okay, and then we will have a look at writing audit logs and adding full-text search features to an application. All of these are features that we require in more and more modern applications where it's no longer good enough to just store some data in a database and hopefully get it back when we need it. Who am I? My name is Thorben Janssen. I'm solving problems with Hibernate and JPA, doing most of my daily work. That means I'm doing consulting, I wrote a book about Hibernate, I'm doing training, coaching, all of these things. Okay, so let's dive right into the multi-tenancy part. In general, there are 3 ways to implement multi-tenancy, and I want to take a closer look at all 3 of them right now. The first of them is separate database. So there the general idea is that we have one application that can be used by multiple tenants, but these tenants are completely separated from each other. You can think of basically every software as a service that you know. If you look at, well, in the easiest case, an email provider, for example, if you go into your Gmail account, you want to see your emails, but not the ones from anyone else. And you also don't want anyone else to see your emails. So we need to separate that data. And that's the same with all other applications that are operated as a service. So with separate database, we take a pretty simple approach and say, okay, each and every tenant gets its own database. So we have one big application, and then we connect to a specific database for the client, for the tenant that's currently logged in and executing one of our use cases. This can be handled on a connection basis, obviously. The second approach is the separate schema approach. There we have just one database server, but we have multiple schemas, one for each tenant. So there, all tenants share the resources of the database server, but we separate the data by putting them into different schemas, and we can also implement that by using different connections for each tenant. And then there's the third approach, which is partitioned data. That's the approach that, in my experience, most teams want to start with. And it puts all the data within the same database, the same schema, the same database tables, but they add an additional discriminator column to identify which tenant owns which record. Unfortunately, that's not supported by Hibernate. The reason for that is simple. Hibernate implements the multi-tenancy feature based on connections, and you can't do that with the partitioned data approach. Here you would need to adapt each and every SQL query. That's currently not supported by Hibernate. If you want to use this feature, then you should take a look at Eclipse Link, for example, who offers that. Okay, enough theory. Let's get into the IDE and take a look at how we can implement that. And as you will see, that's pretty simple. You just have to implement 2 interfaces. First of all, you need to implement the current tenant identifier resolver interface. And this has only 2 methods. You can see the 2 methods here. And the reason why you need to implement that is simply that user authentication and mapping a user to a tenant is far outside of the scope of Hibernate. That is something that you do in your either authentication component or maybe in a servlet listener if you are using a REST API, for example. So we need to implement a class that tells Hibernate who the current tenant is. And in most cases, the resolve current tenant identifier method would get the current tenant ID from the thread local, for example, where the authentication component put it during the login. In this example, I tried to keep the complete stack pretty simple, which means I have a Java SE application or test case and just use Hibernate without any additional frameworks. So I did a dirty hack down here and introduced a setter method for the current tenant ID. You would probably not have this method in a real application. And then you need to implement the multi-tenant connection provider interface, or what is a lot easier is you extend the abstract multi-tenant connection provider class that's provided by Hibernate. If you do that, you just have to implement two methods: get any connection provider and select connection provider. The interesting one is the second one, which gets the current tenant identifier. That's the one that we returned here. So Hibernate uses it to call this select connection provider method, and it returns the connection provider for that specific tenant. In this case, I have a map with all connection providers for all tenants. The implementation of this method highly depends on your technology stack that you are using. I mean, if you're building a multi-tenant application, you normally have a pretty advanced stack, which means you have a Jakarta EE server or maybe a Spring Boot application, and I'm pretty sure that you have connection pooling in place. So here you would get a connection provider for the specific connection pool for the tenant that's currently logged in. And that's all you need to do. After you've implemented these two interfaces, you are basically done with your multi-tenancy application, and you can then do something like I do here. It's a simple test case. Let's ignore this line for now, and I just open a session, start a transaction, instantiate and persist a new book, and then commit the transaction. So this part should look very familiar to you. That's what you do in either this way or in a pretty similar way. I mean, more advanced stacks, you have this part somewhere handled by the framework, but at least this part should look familiar to you. That's what you do in your application. There's nothing that's multi-tenancy specific. The only line that looks a little bit strange is the one that sets the tenant identifier. But as I explained previously, that's a hack. Normally you have your authentication component and your servlet listener or any other component that sets this on the thread local, and you don't need that. So to sum it up, there is no specific code that handles multi-tenancy within your application. You just have to implement these two interfaces, and that's it. That means you can add multi-tenancy later on to your application without changing anything. But in this test case, I then also do the same code again, just for tenant 2, and persist the second book. So let's run this test case and see what happens. Well, these are the SQL statements that Hibernate executed. You can see again, there is nothing multi-tenancy specific. You don't even see that Hibernate works with multiple tenants. It just gets a new value from the sequence, then it persists a new book, and then it does the same again. And if you take a look at our database, then I have here tenant 1 as a schema. And you can see that in the book table, there are only records for the tenant 1. And I have the same in schema tenant 2. And you can see here that there are only the books of tenant 2. There's one thing that I forget to show you. There's a little bit of configuration you need to do. Where is it? Here's it. So you need to define which version of multi-tenancy you want to use. In this case, it's Schema. And you need to configure the name, the fully qualified class name of your tenant identifier resolver interface, and the same for the connection provider. But that's also something that's pretty independent of your application code. So you can add it later, remove it, do whatever you want with it. And that's all you need to do for multi-tenancy. Any questions about multi-tenancy with Hibernate? Okay. So then let's take a look at the next more advanced feature, audit logs. Who writes an audit log in his or her application? It depends. Yeah, it depends is a pretty good answer. Well, in most applications, we don't introduce audit logs just because we want to do it. And none of our customers normally just decides, well, I would like to have an audit log. No, normally there are legal requirements that force us to write an audit log, or someone needs that feature in the UI. So let's quickly define what is an audit log and why could we need it. Well, there's this pretty complicated definition of an audit log that I got from Wikipedia. But to summarize it in simple words, it's, well, we should document all changes that were performed on the database, which means we need to document all insert, update, and remove operations. Why do we need that? Well, for some industries, there are legal requirements to have such an audit log. And in other cases, we just want the user to be able to see the history there of all operations that were performed on a specific object. Like a customer care employee who wants to see, okay, what changed on this specific customer? When bought he which product? Why is the name on the invoice different than the one in the system? Take a look at the audit log. Well, that person married and changed the last name. These are questions that we can answer with the audit log. And well, there are multiple options to implement that. You can do that completely on the database side and use database triggers, which write the information into an additional table. You can implement it yourself in your business code, for example, and persist additional entities for each insert or update operation. But I think we all agree that we don't want to manage this technical detail ourselves. I mean, who wants to create additional entities and persist all or additional records for each operation? Third option is we could use Hibernate Envers. Hibernate Envers is a component that integrates into Hibernate ORM and uses lifecycle listeners to write audit records for each write operation that we executed on the database. This has the huge advantage that it's extremely simple to use. We don't need to do, well, almost anything, as I will show you soon. The downside of that is we can only audit the things that were performed via entity lifecycle state transitions, which means if someone connects directly to the database or if any other application works on the database, Hibernate Envers doesn't know about any write operations that are performed. If we are using bulk queries, then Hibernate Envers also can't write any audit logs because then we don't have any entities that perform lifecycle state transitions. But as long as we instantiate a new entity and persist it, or update an existing entity by changing its attributes, or remove an entity via the entity manager, all of these operations can be audited with Hibernate Envers. And besides that, we also get a very powerful query API that allows us to take a look at the audit log, search for specific information within the audit log, and well, basically work with the information that we collected. So what do we need to do to add Envers to our project? Not a lot. We need to add the dependency. Well, that's not a big surprise. Then we need to annotate our entities that we want to audit with the audited annotation. And that's all that we need to do on our Java code. And then we need a few tables in the database. I mean, we need to store this audit information somewhere. So we need a revision table. By default, that one is called revinfo. And then we need an audit table for each entity that we want to audit. So basically, a history table for each entity. So let's get into the code and take a look at it. Let me close this. So here you see my simple author entity. I just annotated it with audited, and I did the same with my book entity, and there's, besides that, nothing special about these entities. And I also added this dependency to my POM XML, which is just a simple dependency to Hibernate Envers. And that's all that we need to do, at least if we want just to use the default operations to audit it. So let's do a quick test. I get an entity manager, start a new transaction, and then I persist a new book entity. Close this, commit the transaction, close the entity manager, start a new transaction, and update this book entity. So what does Hibernate do? Here you can see the SQL statements that Hibernate executed. Well, the first two are pretty normal. Hibernate gets a new value from the sequence as the primary key, and then it persists the new book entity. Well, that obviously needs to be done, and that is what we triggered in our code. The following statements are executed by Hibernate Envers. So it first writes a new record into the revinfo table, which stores the revision. And it gets an ID and the current timestamp. So now we have the information when it happened. Then Hibernate writes an additional record into the book aud table. That's the audit table of the book entity. And as you can see here, it has the publishing date title, publisher ID, and ID. These are the attributes mapped by the book entity. And then we have the ref, which is the reference to the revision, and the ref type, which is a beautiful one-digit number, 0 for insert, 1 for update, 2 for delete. Not the most informational way to present this, but as soon as you get used to it, it's pretty simple. And then we start the update by first selecting the book entity, and then Hibernate updates it, and then we get the same. We write an additional record into the revinfo table and an additional record into the book audit table. So now we have 2 revisions in our revision table and 2 different versions of the book. And we can answer what happened when. Well, storing these information in the audit is nice, but pretty useless on its own. In the next step, we probably want to somehow work with this information. We want to present it to a user, we want to search for specific information, and if we do that, then we have 2 ways to look at the data. Audit data gets an additional dimension because we track the changes over time, as you can see here in the image. And we have 2 ways to look at it. Either vertical, which means we take a look at a specific record in this case, the book with the ID 2, and see how it changed over time, or the horizontal view, where we take a look at the database content that was valid at a specific point in time. So the vertical view is something that our customer care user can, for example, use to see the history of a customer and what changed on that record. The horizontal view is something that we can use to find out which data was valid on maybe last Monday when a strange incident happened and we don't really understand how the system reacted and what was going on there. Hibernate Envers allows us to implement queries for both kinds of views. So let's start with the vertical one. And therefore, we first get the audit reader and then create a query, and there's a method called for revisions of entities, for entity. So there, we get all revisions for one specific entity. We define the class of the entity. The second parameter tells Envers if it should just return the entity that was valid at that specific revision, or if it should also return revision information. We'll get into the code and use both options. And then we can decide if we want to see deleted entities or not. Deleted entities don't contain any information. So that is just an additional record in the audit table with the primary key, the link to the revision, and the revision type deleted or removed. So let's take a look at this. So here at the beginning of this test case, I just create a new book entity, update it, and then I want to see all the changes that were performed on this specific entity. So I first used the audit reader factory and the current entity manager to get an audit reader. Based on these audit readers, we can now define our queries. So here I create a query, tell it, okay, I want to create a vertical query for a book entity, and I only want the entity information, and I also want to retrieve deleted entities. And then I create an additional predicate for that query and say, okay, the ID of the audit entity, which is the book, should be equal to the ID of the book entity that I instantiated and updated up here. And then I write all the audit information to the log. And here we can see that we get both entity versions from the audit log. First of all, with the short book title, and then with the updated one. And it was retrieved with this query, which is pretty simple. We just select all columns from the book audit table and then limit it to the record with the given ID and order it by the revision so that the returned versions start with the first one. Another thing we can do in the vertical view is we can answer the question in which revision a record got a specific value. So let's try to find out when, with which revision we introduced this long title of the book. We again do for a query, create query, and then for revisions of entity. This time, I also need the revision information. So I set the second parameter to false and create a projection that returns me the smallest revision number and create an additional predicate limiting it to the specific title. As you can then see in the log, Hibernate returns the revision ID 3. Well, in this case, I'm using the same sequence for the book and for the revision. So we used ID value 1 for the book, and then 2 for the first revision, 3 for the second one. Well, in addition to the vertical view, we can also take a horizontal view at the audit log. So there we go back in time to a specific timestamp and take a look at the data that was valid at that point in time. So in this case, we use the method for entities at revision and provide a revision number and a class that we want to retrieve from the audit. And I also prepared an example for that. You can see that here. So in this case, I create a new book with the publisher and get the date directly after the creation of these records. And then I can say, okay, give me an audit reader, and then audit reader get me the revision number that was valid at this specific point in time. And after that, I can use the audit reader to create another query to get the book classes that were valid at this specific revision. Join that with the publisher and, for example, check, okay, I want to get all book entities that use the word JPA or Hibernate in the title and that were published by a publisher named Thoughts on Java, and return them in the ascending order of their title. Okay, and here you can see that we found one book with this incredible generated SQL statement. You have to be a little bit careful with complex queries and Hibernate Envers. It works in general, but sometimes it gets a little bit messy, and you definitely have to review the queries, and there are certain ways how you can optimize your audit log for specific use cases. So you can decide if you either want to optimize it for fast write operations, or if you want to store additional information that makes these kind of queries a little bit easier and faster to execute. Well, now I've shown you how you can set up Hibernate Envers, add it to your project, audit all changes, and get the data from the audit log. But we just answered two questions. What happened? When? But especially if we have to fulfill legal requirements, we have to answer a third question. Who did it? That is something that Hibernate cannot do on its own, because that would require user information, and any authentication is far outside of the scope of Hibernate. But you can easily add that yourself by implementing your own revision entity. And don't worry, that's a lot easier than it might seem in the beginning. You just need to extend Hibernate Envers default revision entity, which contains the attributes that we saw, which means the revision ID and the timestamp and all the mappings that are required. Add your own information, in this case username, and annotate it with entity and revision entity. The revision entity annotation references a listener that you need to implement as well, and that gets called with the instantiated revision entity, but there are certain attributes that we added to the standard revision. For these attributes, Hibernate doesn't know how to get their values and how to set them. So we have to implement that in our revision listener ourselves, and in this case I just set the username here. And that's all that you need to do in the listener and the entity. And if I now, let's take a simpler, let's take this one. So now Hibernate stores these information in the audit log. And you can also use them for your query. Here, for example, I create a query that checks that that gets all revisions of a book entity and checks that the username is equal to user1, which is a query that's probably a little bit problematic from a data protection point of view, but it's good enough for this example. So I can see here that I now retrieved the revision information, and I can, for example, answer the question, what did user 1 last Monday? Which might be interesting if I know that there were a few things that went wrong on that day, and that I might need to go back and clean up some data. Okay, questions about Hibernate Envers and writing audit logs? Yeah? No, it writes them to the same entity manager, uses the same entity manager and persistent context to write the information, so it would be the same. But you can solve that on the database side, for example, by mapping these audit tables into your schema. Any other question? Okay. Then let's get to the last topic, which is full-text search. Full-text search is a pretty common requirement, which is most often described as, well, I want to search like Google. I just enter something in the search field and it searches basically everywhere, and it finds similar strings that are not an identical match, for example, different spellings of the same word, and these kind of things. And that is incredibly difficult to implement with plain SQL, but it's a thing that's very simple if you are using a full-text search engine. And with Hibernate Search, you can do that. Hibernate Search integrates either Lucene or Elasticsearch with Hibernate ORM. How does it do that? Like this. So Hibernate Search integrates into Hibernate ORM, and whenever you write something to the database that's also indexed for full-text search, it updates the full-text search index. Or you can do a full-text query, then it executes the query against the full-text search engine, retrieves the IDs, and then uses these IDs to get the records and matching entities from the relational database. And the main benefit here is that you don't need to take care that your relational database and your full-text search index are in sync. That's handled completely transparently by Hibernate Search. So what do you need to do to add Hibernate Search and full-text query support to your application? Well, not a lot. You again need to add the dependency to Hibernate Search. That shouldn't be a surprise. And then you need to define which entities should be indexed in the full-text search. And you need to annotate them with indexed. And then you need to define which fields should be available for the full-text search, because Hibernate Search isn't adding all the fields to the full-text search engine. It just adds the information of the fields that you identified as the ones that you want to use for your full-text search. So if you add Hibernate Search to your project, please spend some time in the beginning and think about which attributes of your entities do you want to use in your full-text search. because you can only perform a full-text search on attributes that you added to the index. If you decide later on that you want to support additional fields of your entities in the full-text search, then you can do that, but you need to rebuild your index, which creates additional effort and takes some time. Okay, and after you've done that, you can use a JPA-like API to define a full-text query. We will take a look at that very soon. So what does Hibernate Search do? Well, it creates a query for either Lucene or Elasticsearch based on the query that you defined via the Hibernate Search API, similar as you can do it with the criteria API for Hibernate ORM. And then it performs this query based on the indexed fields and gets back the ID of the records that match your full-text query, and then gets to the database and retrieves the entities. And you do that in basically 4 steps that you can see here. I don't want to talk about that too long because we just go into the IDE and take a look at that. So here I created a pretty simple example project in which I indexed a bunch of Twitter messages. So I created the entity tweet, an ID, a posted ad, a username, and a message, and a few more information. Annotated that one with entity, so that it's a managed entity that's handled by Hibernate ORM, and with indexed, so that Hibernate Search creates indexes on the full-text search engine and manage the information there. So the analyzer dev is something that you can ignore for now. We will talk about that soon. And then I annotated the message and the username field with field and tell Hibernate Search, okay, please store these information in the full-text engine. And I also annotate the posted ad attribute also with field and with a date bridge, which allows me to define the resolution with which these information are stored in the full-text search engine. That is something you should definitely take a look at if you want to work with dates in your application. So here I have a simple test case that executes a full-text query, and you can see the query here. So what do? I first get a full-text entity manager. And that is an entity manager version that is extended with the full-text query capabilities. And then I create a query builder for the entity tweet. So now I define, okay, I want to perform a full-text query on a tweet. In the next step, I say, okay, I want to do a keyword query on the field message, and it should match my search term. And after that, I have a full-text query that I can provide as a parameter to the create full-text query method and just execute it. Let's take a look at the output of the test case. So here I'm using Lucene. It works pretty similar with Elasticsearch, which is supported since Hibernate Search 5.6. Currently we have 5.9. No, I think 5.10 was released a few days ago. And the support for Elasticsearch gets better and better. And there will be a few more changes to abstract the API, which is now pretty close to the Lucene operations, so that it will now then be independent of the full-text engine that's below that. So here we see, okay, we execute a Lucene query, message validate, message hibernate. And we get back 2 IDs for these 2 records. So we searched for validate and hibernate. And we can see that the first Twitter message contains the words hibernate and validate. But the second one only contains hibernate. That is something that might surprise you if you work for the first time with full text search or with Hibernate Search. It's similar to Google. There, we don't recognize it immediately because there are just so many results that match our search parameters. But a full text search engine, in this case, for this specific query, basically combines both parameters with an OR and ranks them based on certain criteria. In this case, it's pretty simple. A tweet that contains both words, hibernate and validate, is obviously a much better match for our query than a tweet that just contains the word hibernate. Now, that's something that, sure, we could also implement with SQL. Maybe not that easily, but we could do that. But what we can't do is what I want to show you now before we end the talk. So now I'm adding analyzers. The idea of analyzers is that I do some pre-processing on the data that I add to my full-text search index so that I'm then able to perform more advanced queries. I, for example, want to be able to search for validate and find all tweets that contain the words validate or validation or validator, which are all different versions of the same word. So what do? I create such an analyzer. This one is specific to Lucene. Hibernate Search can also translate it to work with Elasticsearch. But if you're using Elasticsearch, please take a look at the documentation and use the Elasticsearch specific features so that you can really benefit from it. So here I'm defining a text analyzer, and I start with the standard tokenizer, which basically tells Hibernate Search to split my message into different words based on, so a word ends as at a blank, at a dot, at a comma, and so on. And after I've split the message into different tokens, I can then apply additional filters on these words. First of all, I transform all words into lowercase, which is something that we would also do in SQL. So we want to find, we don't want to make any difference between validate in uppercase and validate in lowercase. I mean, it's the same word. Should handle it in the same way. And then I use this snowball porter filter, and there we get stemming. The idea of stemming is that we reduce each word to its stem form. So that's, you see that in the test case after I've activated it, which is basically the same version of, or the stem form of the word for validate. So I activate the analyzer for the message field, and then let's run this. Oh, there was a wrong test, this one. So here I'm now searching for validate, hibernate, validation, hibernate, and validation in uppercase hibernate. And you can see here that the query that Hibernate Search sends to the Lucene index is the same in all 3 cases, because there's basically no difference between validate, validation, and lower and uppercase. It all gets reduced to valid, and Hibernate gets reduced to Hiban. And as long as we apply these filters when we write the information to the index and when we perform the query, we can make sure that basically these three queries all return the same information. Okay, that should be it with my short introduction to Hibernate Search and full text search in Hibernate. Any questions about that? No questions? Okay, and then I was asked about the speed of the search. Well, in general, Lucene and also Elasticsearch are incredibly fast. But we have to be aware we are now communicating with an additional system. So now we are performing a full text query against the full text index, and then we perform an additional select statement to get the entity from the relational database. So we are obviously slower than we would be without the full text search and query. But on, I would say, most normal scale systems, we don't really have to worry about the performance. Lucene and also Elasticsearch are high performant, really solid implementation that you might, yes, need to tweak for performance, but there's good documentation for that. But there's normally no performance requirement that you should worry about for normal scale applications. Yeah. Well, sure, you could do that asynchronously, but you can also do it synchronously. By default, Hibernate Search keeps the full text index and your relational database in sync. So each and every operation that you perform on an entity gets written to the relational database, and the index gets updated. So it's available immediately afterwards. That depends on your configuration. You can decouple that.
Can you show the configuration combined with the
So I have no example for Elasticsearch here, but the configuration for Lucene or Hibernate Search in general is pretty simple. You just need to add the, where is it? Here, the Hibernate Search ORM artifact to your POM XML. And then you can add these two parameters to your persistence XML. But these are not needed. The file system directory provider is used by default. In this case, I wanted to make sure that I specifically know where the index is located so that I can take a look at it. And there are also distributed versions of the Lucene index, but I recommend to start with this one because it's very easy to take a look at it and really understand what's going on within the index, what's happening with the queries. Full text search, especially if you apply filters and stuff like that, gets really complicated very quickly. So it's a good thing to be able to take a look at the index, and so that you can at least try to understand what's happening there. More questions? Okay, then thanks for your attention. If you want to get in touch with me, you can either use the Twitter handle down here or visit my website and reach me via that one. Yeah, and I'm available for more questions now after the talk. Thank thank you very much, and enjoy the rest of the conference.